Hi students, the subject name is EE8010 Power System Transients. Today we will learn the basic concept of double frequency transient. First we will discuss what is meant by double frequency transient. We have considered any one of circuit and that circuit divided into two parts. First one is source side and second one is load side. In these two parts can be separated by using circuit breaker. That means it act as a switch. When a switch is open, that means if any fault occur in that power system, the switch, that means the circuit breaker will be open. When the switch, that means circuit breaker will be open in a single phase circuit, the recovery voltage to reach a value of twice the range of normal peak value, that means normal peak voltage of the system. In that system, if any fault, that means single line to ground fault or double line to ground fault, that means any fault occur in that system, the value of recovery voltage twice the range of normal peak voltage of the system. In each fault the circuit breaker will be open. At that time the arc will be produced. After the fault is clear, the arc can be extinguished. This is the main thing of double frequency transient. This is the basic circuit diagram of double frequency transient. That means it's the circuit of two natural frequencies. That means V is act as a voltage source. L1 and C1 is considered as source side, and L2 and C2 will taken as a load side inductance and capacitance. L1 it denotes as inductance of source side. C1 is nothing but stray capacitance on the source side of the breaker. We have considered unloaded transformer. We can derive the equation of double frequency transients. Okay, next. This is the waveform of double frequency transient, and the dotted line denotes the normal system. That means this is a normal after the fault is clear, or if any one of the fault is taken before the system, the waveform is pure sine wave. If any fault occur in that system, the waveform will oscillate. That means the transient recovery voltage will be created. The arc voltage also created across that circuit breaker. In this circuit, in this derivation, first we have considered the switch will be open and the voltage across the capacitor will be L2 divided by L1 plus L2 into V. L2 is nothing but load side inductance, L1 is nothing but source side inductance. We know that L2 is maximum more than L1. That means the regulation will be very poor. The capacitance of source side and load side, that means C1 and C2 will be charged to something little less the instantaneous system voltage. So the following interruption of the current, C2 will discharge through the inductance L2, that means the load inductance L2. The natural frequency will be given as F2 is equal to 1 divided by 2 pi square root of L2 into C2. Next, meanwhile C1, next consider the source potential. The system will be F1, that means is the natural frequency of source side. F1 is equal to 1 by 2 pi square root of L1 into C1. This is the waveform of source side and load side. And next final diagram is recovery voltage across a circuit breaker switch. The circuit breaker is only is the main part of dividing the system. That means is to separate the system source side and load side. This is the main example of double frequency transient. We have considered the unloaded transformer. The transformer primary is connected to source and secondary of the transformer is connected to the circuit breaker and the inductance and capacitances. In this circuit, the circuit breaker clearing a short circuit on secondary side of the transformer. In this circuit, L1 denotes inductance up to the transformer, L2 denotes leakage inductance of the transformer, and C1 and C2s are inherent capacitance on either side of the transformer. So we can to determine the recovery transient voltage. This is the main equation of transient voltage. Vc1 is nothing but voltage across the capacitor C1. We have considered in this circuit the capacitor C1, the flow of current is I1 and I2. So the capacitor across voltage Vc1 is equal to V minus, V is the total voltage, that means is the source voltage, V minus L1 into di1 divided by dt is equal to, in terms of capacitance, by applying KVL, Vc1 is equal to Vc1 of 0 plus 1 by C1 integral of I1 minus I2 into dt. This is the equation 3.4.4. The next equation Vc2 is nothing but the voltage across the capacitor 2 is equal to 1 by C2 integral of I2 into dt. That means in capacitor C2 only the flow of current I2. So next equation in terms of inductance, Vc2 is equal to V minus L1 di1 divided by dt minus L2 into di2 divided by dt. In this equation 3.4.4 and 3.4.5, 3.4.6 is the basic equation. In these equations can be taken as the Laplace transform, and equating the equation 3.4.4 and equation 3.4.6, we get the next equation V by S minus L1 into S into I1 of S minus L1 into I1 of 0. I1 of 0 is nothing but in initial current of the capacitance, equal to Vc1 of 0 divided by S plus 1 by C1S of I1 of S minus I2 of S. In this equation can be rewritten as the equation 3.4.7, and next 3.4.8 is denoted as the capacitance across the voltage V2, and next equation can, in this next equation the 3.4.6 equation can be rewritten as, that means we have taking a Laplace transform of 3.4.6 equation can be rewritten as 3.4.9 equation. And next in this equation 3.4.9, the value of current I1 of 0 and I2 of 0 equal to 0. That means is when the switch clears at the current 0 position, the time is measured from the instant I1 of 0 is equal to I2 of 0 is equal to 0. We have substitute these values in above equations 3.4.8 and 3.4.9. we get the new equations I1 of S, and this is the equation of new equation, and multiplying through the equation 3.4.1 by using S square divided by L2 into C2. So and next we can write the equations. Finally we get the quadratic in form of S square, and this is the final equation of double frequency transients occur in quadratic form. And the next one is arcing ground. Arcing ground is nothing but is a grounding technology. If any one of the fault occur in that any system, the neutral of a three-phase wire is not earthed is a long time, the voltage of the transmission line is have a double the range of frequency and voltage. So it's a series problem occur in that power, that particular line, for the particular three-phase or single-phase line is called as arcing ground is produced. That means if any one of the fault occur in that system in the new single phase or three phase system, if the neutral of wire is not earthed to the overall power system called is a series problem occurs. So in this system is called as a arcing ground. In this ground if this problem occurs, so we produce several oscillations of 3 to 4 times of the normal voltage. This is the main thing of arcing ground. Next one is ferro resonance. Is in this condition is very important to study of power system transients. In this ferro resonance condition, it will be causes high transient voltage in the power system. So in usual or transmission line, the capacitance is very small, so that resonance is rarely occurred in power system at normal frequency ranges only. So however, if any of the generator EMF wave is distorted, that means any EMF is generated distorted in the generated side, the trouble of resonance may occur due to the fifth, or only for higher harmonics will be produced. This is the main thing of ferro resonance. Okay, thank you.